of a molecule. Okay? And we'll start off with some basics here. Just when we'll look at the formula of a compound. Okay? First off, let's define compound again. What is a compound? Word?
Elements combined.
Yeah. Two or more elements joined together, or we might say bonded together. And when we are writing the formulas for compounds, we use numbers to indicate a couple different things. Sometimes we may use a coefficient. And a coefficient is this number that precedes the compound, that comes before it. It's written as a large, normal-sized number, okay? And that's the coefficient. What that tells us is how many molecules of that compound we are referring to. So in this case, we're referring to 4 water molecules.
Oh, that's what that is.
Oh, I thought it
The subscripts, the smaller numbers that are within the formula, those indicate how many atoms of a certain element there are. So obviously in H2O, the 2 is telling you there are 2 hydrogen atoms. Now what if there is no coefficient, or if there is no subscript? That's assumed to be what? Does that mean 0?
No, it's just it's a plain element like that. Sounds just
1.
Yeah, but it means 1. So if there's no subscript, it's inferred that there's 1 of them. And we use these coefficients and subscripts to help us sort of condense and make things a little neater when we're writing out the formulas. You know, you could write 4H2O without the coefficient and write H2O, 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 H2O. We could write 4H2O without the subscript and write 4HHO. And they all basically are telling you the same thing. So the first step in understanding how we determine the mass of a molecule is to figure out how many atoms there are of each element. Okay? And so, for example, this aluminum oxide, Al2O3, is the formula. First off, there's no coefficient, so what does that mean? There's 1 molecule of this. How many atoms of aluminum are we referring to due to the subscript? 2. So the total number of atoms of aluminum are 2.
2.
Oxygen. First, again, we need to know how many molecules of this whole thing there are. There's no coefficient, so it's 1. We need to know the subscript of oxygen. 3. There's through that 1 times 3 tells us there's 3 atoms of oxygen. So obviously that's a fairly simple example.
Wait, how come 2 plus 1?
It's not. We multiply the number of molecules times the subscript for each element. Herschel?
Now, for the molecules thing,
Yep.
say if there was more than 1 molecule,
Yep.
would it go in front of the O or in front of the AL?
It would be in front of the AL. So like if there were 4 here, how many aluminum atoms would we have?
8.
8. We would multiply 4 times 2.
Oh, okay.
Now, sometimes we have parentheses in our chemical formulas. And so we use parentheses often to denote that a group of atoms is acting as a unit. Sometimes we call them radicals. So this is nitrate, the radical nitrate, NO3. And in this case, how many of these nitrate radicals do I have? 3. I just look outside the parentheses. So this first subscript, this 3, what does that go with? Only goes with the oxygen. What does this 3 outside the parentheses go with? Yes, the entire unit, the N, the and the O. All right, so if we put together the parentheses and the subscripts and the coefficients, we can do a more complex example. So now we have a compound here. again, we start by just listing whatever elements there are. In this case, all we have is hydrogen, carbon, and oxygen. How many molecules of this am I talking about in this example? Nicole? 3. My coefficient is 3. What's my subscript for hydrogen? 2. So how many atoms of hydrogen are there?
2.
Yes. Okay, let's look at the carbon. Again, how many molecules of this whole thing? 3. And what about the subscript for carbon? We need to look at it inside and outside the parentheses. What's the subscript inside? 1. Right? There's no subscript here.
Oh, carbon.
And then this 3 also goes with it, correct?
Yes.
So 3. So the total number of carbon atoms is 9.
How come that's not 4?
4. Oh.
For carbon?
1 plus 3.
Because this 3 you multiply 3 times 1. All right, and how about the oxygen? First, number of molecules? 3. Subscript inside?
3.
Outside?
3.
Okay, what are we going to get? 9 total. So the total number of oxygen atoms?
27.
Yes, it's 27.
21.
So is that clear how we arrive at these numbers?
Yes.
Nicole?
Is the 7th subscript that only applies to the number and all of them in parentheses?
Everything in parentheses. So if there's a subscript directly after the parentheses, it applies to everything that was in the parentheses.
Yeah, because I was confused over it.
All right, well now we're going to add in one more step. If we want to determine the mass of that whole molecule, we follow the same steps, but once we know how many atoms of each element, what do we need to multiply it by?
The mass.
The mass of each element. All right, so let's do some examples. All right, so again, this first one, we have 3 elements. We have sodium, nitrogen, and oxygen. So we list them out, the elements. All right, how many molecules of this whole thing are we referring to?
1.
Just 1. Now we need the subscripts. So for sodium, what do we have?
1.
Just 1. How about nitrogen?
Not 1.
1. How about oxygen? 3. Now I need the atomic masses. This is why we need our periodic table. Sodium, Bianca?
Wait, I have a question.
Okay.
23.
Why did they put NO subscript 3 in parentheses if there isn't a...
Because that still is acting as a group together. Even though there's no subscript after it, that nitrate is a radical that acts as sort of its own molecule, its own element almost. All right, atomic mass. Eli, what's sodium?
23.
Nitrogen, Chloe? And oxygen? Eventually you'll know some of these from memory. Morgan? 60.
What if we can't?
It's okay. All right, finally, or not finally, second to last step is I multiply. Okay, the molecules times the number of atoms times the atomic mass. So, what do I get for the sodium? 23. How about the nitrogen?
14.
And oxygen?
48.
Wow, math geniuses.
And our total mass then of this whole compound?
8 of us.
85.
Tristan? What?
84.
85 AMU.
80.
So the mass of this whole compound is 85 AMU. All right, hydrogen chloride. This is hydrochloric acid. Real simple. Yeah, we just have hydrogen and chlorine. It's just 1 molecule of each, 1 atom of each. Atomic mass of hydrogen, we should all know by now.
1. See, that's easy.
Chlorine,
5.
35. So the atomic masses. And our total? 36 AMU.
So wait, what is that? Is that an I?
That's
or
Cl chlorine.
Olivia?
Olivia?
I don't get it. Like, I don't get how you found
I don't get it.
So molecules, we're always just looking at the coefficient that comes before it. So again, here it was 1, here it was 1. In a minute, in an example, it'll be something else other than 1. And maybe it'll become clear.
But
Okay?
there's no one.
Right, so if there's no coefficient, it's assumed to be 1.
Oh.
Just like when there's no subscript, it doesn't mean there's no, like here there's no subscript for hydrogen, it doesn't mean there's no hydrogen, it means there's one hydrogen atom.
That's kind of weird. Though.
All right, carbon dioxide, again, this is, well, I'll just click through here. This is too simple for us.
Okay. Hold up.
All right, so let's get a little more complicated. I'll finish writing that down. The next few are a little more challenging.
Got it. Now.
Again, if you know the procedure and you know the steps, it's really not much more complicated, just slightly bigger numbers. All right, so let's look at this. So we have 4 C12 H22 O11. Again, we all need to start the same way. We list the elements. Here it's just carbon, hydrogen, and oxygen. Now I need to know how many molecules of this whole thing am I referring to, Nicole? Yes, there's 4 molecules. That's why we have that subscript. Okay, now I need to know the number of atoms. So, for carbon, how many atoms of carbon are there, Olivia?
12.
There's 12 is a subscript. Let's multiply it times the molecules now. So, 48 total. 12, 4 times the subscript, which is 12, for a total of 48.
Oh, wait. Oh, multiple.
Yeah, we'll multiply it out there.
I have a feeling people in the other class.
All right, how about hydrogen? Again, 4 times the subscript of 22. There's 88 atoms of hydrogen. Oxygen, Herschel?
44.
44. Okay, I need the atomic masses. Carbon, Jonathan?
576.
Carbon's atomic mass?
I think the carbon's atomic mass
What's your
is
unit?
12.
Okay.
40.
Hydrogen? 1. Oxygen, we should know by now? 16. All right, so now I just need to do my multiplication. I have 48 atoms of carbon times 12, the atomic mass of each one, gives us, okay, 576. 88. What's the mass of the oxygen?
704.
For a total mass for this whole molecule of?
Ends in an 8.
Yeah, I know. 1,306.
What? Veggie chick patties?
1,368.
Thank you. 1368.
So wait, what molecule, what molecule is that?
That's some carbohydrate. All right.
Oh.
I want to move on. We're going to run out of time. I want to make sure we get to the bottom example. So don't worry about this one right now. It's just like the previous one. But I want to get to one with parentheses. All right. Here, we have nickel. We have chlorine and oxygen. How many molecules of this? 3. Okay. So how many atoms of nickel? We have the molecules, 3, times what's the subscript for nickel? 1. So there's 3 nickel. How about chlorine? What's the subscript? 1 inside, but what about this 3? That 3 also applies, times the number of molecules. So we have 9 chlorine atoms. How many oxygen atoms? No.
Oxygen.
Joey? 27. 3 inside the parentheses, times 3 outside the parentheses, times 3 molecules, the total is 27.
That's confusing.
Then we have our atomic masses, multiply them out, add them up, for a total of 924 atomic mass units.
What is that? That thing. I just want to know.
Nickel chloride.
Seconds.